So today what we want to start talking about is how we can use exponentials and logs to solve equations. We've talked about how we created the log. The logarithm came about because we needed something to be the opposite of the exponential equation. We needed something that could get an exponent, a variable out of the exponent, and so that we could solve it. So we know that logs and exponentials are opposites of one another. But how do we actually use that to help us solve equations? So if we are going to be solving these equations, and these are some good steps to follow in general for any function, but this definitely works for exponentials and logs. The first thing that we're going to want to do to solve that problem is that we are going to want to isolate that function. So that means if it's an exponential, we want to get the exponential part of it by itself. What does that look like? So if I have 2 times 3 to the x plus 1 power is equal to 12. If I'm isolating, I want to get the exponential by itself. This is the only part that has the variable in the exponent. Everything else is fluff. So I want to isolate it, get it by itself. I could have to add, I could have to subtract, I could have to multiply, I could have to divide, but I'm going to have to do whatever it takes to get everything over here that's not the exponential moved to the other side. Log, when we talk about logs, if I have something that looks like this, if I'm trying to isolate the log, I'm interested in only the log and what is inside of the log. Everything else is fluff, but I want to isolate that log and get it by itself. So I might have to subtract the 5, divide by the 3. I'm going to do whatever it takes to get that log by itself. So step number 1 is to isolate. Step number 2, after you have isolated the exponential or the log, is to rewrite that equation as its opposite. You might have thought it was a little funny in the homework when we were take this log and rewrite it as an exponential. Take this exponential and rewrite it as a log. The reason we do that is how we solve these equations. If I have an exponential equation and I'm trying to solve it, I need to rewrite it as a log because that gets that variable out of the exponent. If I have a log equation and I rewrite it as an exponential, it gets the variable out of the log, and then I can solve it. So we want to rewrite it as the opposite. If it's an exponential, you would rewrite it as a log. If it's a log, you would rewrite it as an exponential. They are opposites of one another. So isolate it, rewrite it as the opposite, and then step number 3 is to just finish solving. Many times after you do the rewrite step, you've actually finished solving. X is by itself, and you're just done. But sometimes inside the log, we have something like x minus 3, or up in the exponent, we have x plus 1. So we may still have a little bit of solving to do, but at this point, we're talking about adding opposites to both sides, or dividing both sides by something. They're very simple, basic steps. So these are our 3 steps for solving exponential and log equations. Let's look at some examples. So example number 1. If I have 3 times 2 to the x minus 5 power plus 4 is equal to 16. And this is what I want to solve. So the first thing, if I remember my step number 1 is to isolate the exponential. So I'm looking, I'm like, okay, here's the variable that's in the exponent, and here is what's being taken to that exponent. So this is what I want to isolate. So in order to isolate that, first I'm going to have to subtract 4 from both sides. Because when I subtract 4, that gets rid of that. So now I just have 3 times 2 to the x minus 5 is equal to 12. And then I'm still trying to isolate this. And so I have to get rid of that 3. And I do want to put a warning here. So I'm gonna put a little warning. Never. Hope everybody caught that. Never multiply these 2 numbers. Like ever, ever. Never, never. I can never say 3 times 2. Order of operations won't allow it. This 2 has to have the exponent done first. Exponents come before multiplication. So this 2 has to go to this exponent before it can be multiplied by 3. And since we don't know what that exponent is, that means I can't do it. I can never multiply these two numbers. So in order to isolate the exponential, to get rid of that 3, I'm going to have to divide both sides by that 3. It goes away. And so now I have 2 to the x minus 5 power is equal to 4. So that was step number 1, to isolate. We had to subtract from both sides, divide both sides. Sometimes you don't have that much to do to isolate it. Sometimes it's already isolated. That makes this step be really easy. But that's got to be your first step. The second step is to then rewrite it as its opposite. So this is an exponential, so I need to rewrite it as a log. So if you remember, when we're rewriting, we said that a base is a base is a base. The base never changes. So if this was base 2, then this is log base 2. The base does not change. And so it's always 2 to this power is equal to this number. So the power always goes over here. And remember, the whole point of rewriting this as a log is so that this exponent ends up over here by itself. That's what we want to do. So the exponent goes over here, and what it was equal to goes inside the log. So just remember, your base stays the base. What it was equal to is what is now inside the log, and whatever was in the exponent is now over here all by itself. That is the whole point of rewriting it as a log, is that it gets this by itself. The other thing to remember is that most of the time this is some number that we can just type in our calculator. A lot of times you will end up with a decimal, not always. But log base 2 of 4, remember, log base 2 means 2 to what power? So 2 to what power equals 4? Well, that's the second power. If you forget how to do logs, don't forget you can use your calculator to do it for you. If you have one of the newer ones, it lets you put the base in it. Mine is an older one, so it doesn't. So I have to do the change of base formula. So don't forget your change of base formula. If I'm going to type that in my calculator, I'm going to have to do log of 4 divided by log of 2. If you have a newer calculator, you may be able to just put in the base. But if I do log of 4 divided by log of 2, it will give me 2. So 2 to the second power equals 4. So log base 2 of 4 is 2. And now I have x minus 5. And this is why that third step has to be to finish solving. Sometimes there's still a little bit over here with the x. And so when I look at this, I'm like, oh, well, I need to add 5 to both sides. And so x actually ends up being equal to 7. So that's how I go through those 3 steps to solve an exponential equation. Isolate it, rewrite it, and then finish. If I'm solving a log equation, it's the same 3 steps. So let's say we have log base 3 of 2x plus 1 minus 4 is equal to negative 2. All right, so if this is my equation, the first thing I want to do is to isolate the log. So I first need to isolate the log. So what is the log? Here's log, and here's what's inside of the log. So this is the log and what's inside of the log. So the only thing I really have to get rid of in this problem is the minus 4. So if I add 4 to both sides, all right, so those will cancel out. I will have log base 3 of 2x plus 1 is equal to positive 2. Now, I am done isolating at this point. The numbers in here I can't get rid of. They are inside the log. If I have numbers inside the log or inside the exponent, I can't get rid of them. But anything outside of the log and the exponent, I do have to get rid of. But now this is isolated, so we have moved on to step 2, the rewrite step. So don't forget, when you are rewriting a log as an exponential, just like last time, a base is a base is a base. We start with the base of the log. And we said an easy way to deal with logs is to circle up. So if this is the base, it's going to this power. So that means that I have 3 to the second power is equal to whatever was inside the log. As always, the whole point of the rewriting step is that whatever was inside is now over here by itself. The base stays the same, and then the exponent was what was over here and is now up in the exponent. Again, this turns out to be very useful because 3 to the second power, I can type in my calculator and figure out what that is. Hopefully 3 to the second power you already know. 3 squared is 9. But if it is a larger number, if something that you're not terribly familiar with, don't forget your calculator. You can figure out what that is. And then we're on to that last step, which was to finish solving. So we just finished solving this. So I'm going to have to do a little bit here to get x by itself. I'm going to have to subtract 1. So I get 8 equals 2x. And then when I divide both sides by 2, x is equal to 4. I will say, both of these examples that I gave you, I did pick numbers that would work out fairly evenly, but please be prepared to get decimal answers. When we deal with exponentials and logs, a large majority of the time, we really do end up with answers that are decimals. Don't think just because you get a decimal answer that you have done something wrong. That is not necessarily the case.